Good morning, class. I am Miss G, and welcome to our digital science classroom. Your lessons for the second quarter will be all about Earth and space science, with the first unit, earthquakes and faults. Today, we are going to discuss the first module, which is the relationship between faults and earthquakes. Let us recall, when you were in grade 7, you were able to demonstrate an understanding of the relationship of the geographical location of the Philippines to its environment. Now that you are already in grade 8 under Earth and Space Science, specifically earthquakes and faults, under the content standards, the relationship between faults and earthquakes, you are going to use models or illustration to explain how movements along faults generate earthquakes. At the end of this learning session, you must be able to explain the relationship between faults and earthquakes. You must identify the three types of faults, and you must determine the importance of studying about earthquakes. Before we proceed, let me just remind you the materials that I gave you as an assignment because we will be needing them later in the activities. So you may pause the video and place the materials on your side. To start with, I will show you a video, and after watching, you will tell me what will you do if you are in this situation. Are you ready? Here it is. What you have just watched is an actual video taken during the 1990 earthquake in a school. So what will you do if you are in that situation? Good. You will not panic. Very good. You will do the dog cover and hold in an open space, just like what we always do in an earthquake drill. According to the Philippine Institute of Volcanology and Seismology, or PHIVOLCS, the Luzon earthquake that took place July 16, 1990, has a magnitude of 7.7 and an intensity of 9. This strong earthquake has affected a lot of localities, one of which is Dagupan City. As compared to other earthquakes in the Philippines, the 1990 earthquake is considered so far as unequaled in number of deaths, damage in properties, and psychological shocks. Let's explore more the lesson. Let's do this. For the first part of the first activity, entitled A Faulty Setup, you will be needing the materials that I gave you as an assignment. I assume they're already beside you. Here are the guide questions that you need to answer after the activity. Number 1, as you move the sheets, what is formed in the sand? Number 2, what happens to the lines? Here are the materials that you need, and I know you have already prepared them, right? You have received already a copy of the procedure so that you can follow them step by step. So later on, as I do it, you have also to do it on your own. So let's do this together.
Now follow the procedure step by step. Place all the materials that you need on the table. The first step, spread the newspaper or any paper that you have on the table because we will be doing the activity on this paper. If you have a plastic sheet or scratch papers, just like what I did, you tape them together. Then get your 2 sheets of cardboard and place them edge to edge in the middle. So you can see that they will be forming a boundary. So this is their boundary. Okay. Then pour the sand or the soil along the boundary. Now, if you have finer sand, the better. We'll be pouring it along the boundary. Then, we will use the ruler to flatten the side and the top of the soil. Then, draw two parallel lines in the middle. I'm going to use the ruler to draw the two straight lines. Then, we will move slowly the two cardboards in the opposite direction. Observe what happened. So let's go back to the guide questions. The first question is, as you move the sheets, what is formed in the sand? You are right. There are cracks or breaks on the sand. What about the second question? What do you think happens to the lines? You are right. The lines that are continuous or straight before turn crooked or cracked.
The cracks and breaks that are formed in the sand are what you call faults. In the first part of this activity entitled A Faulty Setup, you have already made your own fault model using the sand. Now I want you to compare the fault model you made in the sand with this picture. Do you see anything unusual? If you look at the picture carefully, you can guess that the road was originally in one piece. But the road is no longer continuous. There are two sections, and one section has moved with respect to the other. Compare what you see in the picture and what you saw in the activity. Is there something that looks like what was formed? Is there something similar? Based on the activity and the picture, you can probably guess what a fault is. A fault is a break or a crack in the Earth's crust, and along the break, significant movement has taken place. Can you spot the fault in the picture? Very good. The fault is right here. The second part of our activity is entitled Stick and Slip. Here we have a model that will explain how faults produce earthquakes. If I slowly pull on the rubber band, the box will not move yet because there is a tape. The tape represents the friction that holds the two boxes together. If I keep on pulling the rubber band, the box jerks forward. This is because the tape came off, and so the house on top of the box falls over. This simulates what happens in real life. Imagine that the boxes as the ground, and the boundary between them as the fault. The energy from inside the earth makes the ground move. Did you know that the immediate source of energy in an earthquake is the elastic energy from a bent rock? There is no movement right away. This is because of friction. Once friction is overcome, the ground suddenly moves and an earthquake occurs. Some scientists describe this process as tick and slip. You heard it right. It's tick and slip, or stick and slip. The Earth's outer shell, the lithosphere consisting of the crust and the uppermost mantle, is divided into a patchwork of large tectonic plates that move slowly relatively to each other. Varying between 0 to 100 millimeter per year, the movement of plates is driven by underlying hot and viscous mantle. The movement of these plates creates stress, and the rocks of the surface may break in response to this. When the rocks break, cracks are created called faults. Can you tell me again what causes faults? Good. Faults are caused by stress in rocks. And this stress is caused by the movement of tectonic plates. There are three basic types of stress: tensional stress, compressional stress, and shear stress. Each type of stress can be described by its movement and how it causes changes in rocks. The following arrows will tell you the direction of the stress movement. Compression squeezes rocks together, causing it to fold or fracture. Tension pulls rocks apart, causing it to lengthen or break apart. Forces that are in parallel but are moving in opposite direction is what you call shear stress. Each type of stress causes a kind of fault. There are three basic types of faults: the normal fault, reverse fault, and the strike slip fault. Normal faults are happen in areas where the rocks are pulling apart so that the rocky crust of an area is able to take up more space. Tension stress causes normal faults. As you look at the two pictures shown, the fault forms two sections, the hanging wall and the foot wall. In a normal fault, the hanging wall is moved down relatively to the foot wall. Reverse faults, on the other hand, happen in areas where the rocks are pushed together so that the rocky crust of an area must take up less space. Compressional forces creates reverse faults. In a reverse fault, the hanging wall is pushed up relatively to the foot wall. Thrust faults are a special type of reverse fault. They happen when the fault angle is very low. The third type of fault is the transform or strike slip fault. The movement along a strike slip fault is horizontal, with a block of rock on one side of the fault moving in one direction and the block of rock along the other side of the fault moving in the other direction. Strike slip faults do not make cliffs or fault scarps because the blocks of rock are not moving up or down relatively to each other. Let us recall what you have learned so far. Can you tell me the three types of faults with the corresponding stress that cause them? Very good! Normal fault is caused by tensional stress. Reverse fault is caused by compressional stress. And the strike slip fault is caused by shear stress. Now describe the three types of fault in relation to the movement of hanging wall and foot wall. Okay, let us see if you can identify. What type of fault is when the hanging wall is pushed up relatively to the foot wall? Your answer is correct. It's the reverse fault. What about when the hanging wall is moved down relatively to the foot wall? You are right. It's the normal fault. What about the strike slip fault? What happens with the two blocks? You are correct. The two blocks of the fault slide past to each other in a strike slip fault. I guess you are ready to learn more. We are almost done, but before you get excited, we have few more things to take up so that you can master everything in this lesson. Now I would like you to analyze and tell me what you can observe with these pictures. Very good. The first picture shows a broken windshield, while the other one is a diagram labeled with different terms. Actually, the diagram can tell us the main features of an earthquake, and we can label each of these features in the broken windshield that you can see here. Just like the broken windshield, which has cracks and breaks that are coming from the center. This one can be seen in the diagram and we call it focus. Directly above the focus is the epicenter, which we can locate in the broken windshield here. The fault lines are the cracks and breaks in the windshield. The fault line in the subsurface can also be identified here in the picture of the broken windshield, only that they are so small to be very visible. Let us study some of the terms that are being used when earthquake is being reported in the news. The focus is the point within the earth where seismic waves originate. It is the part of the fault that has the greatest movement. Remember that the focus is where the earthquake starts. The fault plane is the flat surface along which there is a fault. The epicenter is the location on the Earth's surface directly above the focus. So if your focus is right here, under the surface of the Earth, then the epicenter must be above it on the surface of the Earth. Now that you have already learned the relationship between faults and earthquakes, the three types of faults, the three types of stress, and the main features of the earthquake, it's time for me to test you whether you have really understood our lesson. Are you ready? Now I would like you to get a paper and a pen and please answer as we go along. Are you ready? Here it is. You have 10 seconds per item to answer. Write the letter of the correct answer. Number 1. What term refers to the break in the Earth's crust? A. Fault. B. Focus. C. Stress. D. Epicenter. The correct answer is letter A. Fault. Let's go to number 2. Which of the following statement is true? A. Strong earthquakes are caused by thrust faults because it takes place in a very low angle. Letter B. Earthquakes takes place when rocks cannot reach their breaking point due to low stress. Letter C. The stored elastic energy in bent rocks is the immediate energy source of an earthquake. And letter D. Earthquakes can be felt at the Earth's surface because of radioactive waves underground. And the answer is letter C. The stored elastic energy in bent rocks is the immediate source of an earthquake. Number 3. Identify the type of stress shown by the arrows. Please refer to the arrows drawn. Letter A. 1. Shear. 2. Tension. 3. Compression. B. 1 is compression, 2 is shear, and 3 is tension. Letter C. 1. Tension. 2. Compression. 3. Shear. D. 1. Compression. 2. Tension. 3. Shear. 10 seconds starts now. The correct answer for this is letter D. 1. Compression, 2. Tension, and 3. Shear. Let's go to number 4. Which of the following is the correct match? A. Compressional stress to normal fault. B. Tensional stress to normal fault. C. Shear stress to reverse fault. And D. Compressional stress to strike slip fault. 10 seconds starts now. Time is up. The answer for this is letter B. Tensional stress to normal fault. What about compressional stress? It's the reverse fault. And the shear stress is for the strike slip fault. Let's have the last number 5. Why do earthquakes generally occur at plate boundaries? A. Stress on rocks is low. B. Magnetic pull is greatest. C. Stress on rock is greatest. D. Where most rocks are found. The correct answer in number 5 is letter C. Stress on rocks is greatest. Congratulations, you made it. I hope you have learned a lot today. Again, I am Miss G. Thank you for joining me today till our next learning session here in our digital science classroom. See ya!